All right, so you're a designer, a maker. You get that amazing light bulb moment, that perfect idea for a project. But the real trick, the thing that separates just an idea from something real, is figuring out how to turn what's in your head into something you can actually hold in your hands. So today, that's what we're doing. We're laying out the blueprint for how you get that done. Think about it. You've spent hours, maybe days, getting your design just right. It looks incredible on the screen. The concept is totally solid. But here it is, the question that every single designer, every single student has to face. Can you actually make it? This is the exact spot where so many great ideas just fall apart.
Because let's be real for a second. A design that can't be produced, it's not just impractical, it's not finished. And that's why understanding manufacturing isn't some boring technical thing you have to learn. No, for a designer, it's your superpower. It's the thing that brings your vision to life.
Okay, let's get into it. We're going to break down all of manufacturing into 3 basic ideas. Now, don't think of these as strict rules. Think of them as the main tools in your maker's toolkit. Pretty much every single thing that gets made uses one of these 3 methods. First up, we've got subtractive processes. And the analogy here is just perfect. You're a sculptor. You start with a big block of something, wood, metal, plastic, whatever, and you just start removing material. You cut, you carve, you drill, you take away everything that isn't your final design. And the tools for this are, they're everywhere. It can be something as simple as using saws or knives, the stuff you have in your school workshop. But it also scales all the way up to really advanced stuff like CNC milling machines, or even crazy high-energy tools like laser cutters and water jets that can slice right through steel. All right, next tool in the kit, additive processes. And this is the complete opposite of what we just talked about. If subtractive is like sculpting, then additive is like building with Legos. You start with absolutely nothing, and you add material piece by piece, layer by layer, until your object just appears. Now, the most famous example of this, obviously, is 3D printing. I mean, that's been a total game changer, especially for making prototypes. But additive methods are all over the place. Welding metal together, that's additive. Gluing or fastening parts, additive. Even casting, where you pour liquid metal into a mold, you're adding material to create a form. And that brings us to our third and final method, formation. The absolute best way to picture this is thinking about a piece of clay on a potter's wheel. See, you're not adding any new clay, and you're not taking any away. You're just applying force. You're pushing, bending, stretching it to change the shape of the material you already have. And you see these processes in so many things. Bending a piece of sheet metal for a project, a blacksmith forging steel with a hammer, blow molding a plastic bottle, or extruding an aluminum frame for a window. It's all about changing the shape of something that's already there. So here it is, all in one place. You gotta lock this table in your brain. Subtractive, you remove material. Additive, you add material. And formation, you reshape material. I'm telling you, everything around you, your phone, your chair, your desk, it was all made using some combination of these 3 ideas. So once you figure out how you're going to make your thing, you've got another huge decision to make. How many are you making? And this isn't just about the numbers. This is a massive strategic choice that changes your costs, your tools, pretty much your whole process. You can almost think about it like a ladder. On the very first step, you've got one-off production. That's making a single, unique item. This is perfect for when you're prototyping your major project. Take a step up, and you're in batch production, making a limited number. Right at the top, you've got mass production, where you're punking out thousands of identical things. And here's the catch, the trade-off. Making just one gives you tons of flexibility to change things and test ideas, but the cost for that one item is going to be high. Mass production is the total opposite. You have almost zero flexibility once that assembly line is running, but the cost for each individual item drops like a rock. That's economies of scale. Okay, so theory is great, but let's see how all this stuff, the processes, the scale, plays out in a real-world, high-stakes situation. This is a story about a company that had to completely reinvent how they made things just to stay alive. So picture this. It's 2017. Holden Special Vehicles, or HSV, gets some absolutely devastating news. The Holden car factory, the only place they get their car bodies from, is shutting down forever. Just like that, their entire business model is gone. They had a simple choice: change everything or go out of business. So they chose to change. They decided to pivot. And their new mission was this massive, almost impossible sounding engineering puzzle. Take American cars, built for driving on the right side of the road,
ship them to Australia, and completely remanufacture them into factory-quality right-hand drive cars. And we're not talking about just moving the steering wheel.
So just how big of a puzzle was it? Well, this number says it all. Over 300. That's how many brand new, unique parts their team had to design and manufacture for every single car. We're talking completely new dashboards, new steering systems, new controls, a total re-engineering of the car's guts.
I mean, their new process was intense. Each car would arrive and get completely stripped down to its bare metal shell. Then all these new parts, a lot of them made by local Australian suppliers, would get brought in. They'd remanufacture entire systems using a mix of all three methods, additive, subtractive, formation, before the whole car was put back together on a special assembly line.
And the result of all that work? It was a huge success. HSV didn't just survive, they started to thrive again, building this whole new line of performance cars with a full factory warranty. It's just the perfect example of how knowing manufacturing inside and out isn't just theory. It can literally save your entire company.
Okay, so we've covered the theory, and we've seen this incredible real-world story. Now, let's bring it all back home. Back to you, and back to your design projects. How do you use all this?
What's so exciting is that the future of making things is so much more flexible now. I mean, tech like 3D printing and computer-aided manufacturing, or CAM, has totally changed the game. You don't have to ship a physical thing across the world anymore. You can just email the code, the design file, and someone can print it on the other side. The factory is everywhere now.
So, there you have it. You've got the maker's blueprint. You know the core methods, you get the different scales of production, and you've seen how it all works when the pressure's on. So now the only question left, and it's the most important one, is this: what are you going to build?